Hello, knowledge seekers. Welcome to Remedial Tutorial Academy. In this next example, we're going to do a computation involving arguments and products and quotients. And so just to say what it's saying here, what we want to do is given z1 is I and z2 is square root 3 minus I, we want to compute the argument of the product and the argument of the quotient for these two specific complex numbers. Now, let's start with the argument of the product. The argument of the product is the argument of the first plus the argument of the second from our textbook. And this is true since on both sides we consider actually all multiples of 2 pi added to any specific instance of the argument. This is not true, we'll see, for principal arguments, namely if we put a capital A here and this fails. And we'll see exactly why that happens and what this first equation is telling us. It says to compute the argument of the product, or the angle formed by the product of complex numbers, we need the angle of each of the ones that make it up, that are in the product. Now, we computed the argument for z2 already. That was, well, one of the examples we could have taken, is 7 pi 6. And then we want to know what the argument for I is. Let's just do a quick picture here. I certainly makes an angle of pi hales with the positive real axis, so that's actually the principal argument for I, and so we get a pi hales here. Great. So this isn't quite right. This is a representative. So what we're going to do is we're going to go ahead and add in 2 pi k for any multiple of 2 pi. And now let's add these together. Let's see, pi hales is like 3 pi 6, I think. So 3 plus 7 is 10 pi 6, plus, and then we have all of our 4 rotations that we can add in, and, non-reduced fractions bother me. So we're going to write that as 5 pi 3. All right, so now that is the argument of the product, and that is one way in which we can compute it in this example. Let me also point out that in this case, z1, z2 is I times square root 3 minus I. If you sit here and you do this, this is 1 minus root 3i, and if you compute the principal argument here of z1, z2, what you're going to get is, provided I can do things in my head appropriately, you're going to get minus pi 3. So that's what you should get. And if we were to look here also at the principal argument of z1, that happens to be pi hales, because that's in the right range. And if we looked at the principal argument of z2, that's minus 5 pi 6 from the previous video. And if we add these together, what we're going to get is 3 pi 6 minus 5 pi 6, which is minus 2 pi 6, which is minus pi 3. Aha, they match. This is an accident. If we were, for example, to take 2 points here, say on the line y equals x, this is our w1 and w2. Our w1 would be 3 pi 4, and that would also be our w2. So if you were to add 3 pi 4s to itself, you would exceed pi, so it can't possibly be the right answer. So be careful. Principal arguments do not break down like this. Sometimes they do, but you really have to take them up to all multiples of 2 pi. So our saving grace here is the fact that our answer involves all multiples of 2 pi. Now, the second part of this problem is to compute the argument of the quotient. And so, or this example rather, the argument of z1 over z2 is going to be the difference of the arguments. The argument of a quotient is the difference of the arguments. And we computed this already. It was pi 6, and this one was negative 5 pi 6. I'm going to choose to take the principal argument in this case. You could do 7 pi 6 if you like, and then we take all multiples of 2 pi, so all full rotations. All right, so if we do this, this is going to be like 3 pi 6 plus 5 pi 6 plus all multiples of 2 pi. So that's going to be 8 pi 6 plus all multiples of 2 pi, which is 4 pi thirds plus all multiples of 2 pi. Again, I'm going to note here in this case, we actually took the principal argument for both of our complex numbers, and their difference was not the principal argument.
So notice 4 pi thirds cannot be a principal argument because it's too big. It exceeds pi. So again, with these, although it works for arguments, it does not necessarily work for principal arguments. So just be a little careful. Thank you so much for watching. I hope you enjoyed. Please comment down below what other topics you'd like for me to review. I upload new videos every day. Don't forget to subscribe and share for your friends and classmates. See you next time.